Hello students, for class 9, today I am going to discuss on the remaining part of real numbers of number system. So for class 9 it is real numbers. It is real numbers for class 9. It is the remaining part. Let us discuss on the remaining parts of the real numbers. First is number of digits in the repeating block. Number of digits in the repeating block. Repeating block. Now number of digits in the repeating block, as discussed earlier, rational numbers are of two types: terminating decimal and non-terminating repeating decimal. Now for non-terminating repeating decimal, number of digits in the repeating block, the rule is if n is a natural number which has a factor more than other than 2 or 5, then 1 by n will have a non-terminating recurring decimal expansion. For example, for example, 1 by 7, the maximum number of digits in the repeating block can be 7 minus 1 is equal to 6. Actually, what is the rule? The rule is then the maximum number of digits in the repeating block will be n minus 1. Maximum number, that is, cannot be more than n minus 1. But don't think it is exactly n minus 1. Less than this also can be less than this, but we are finding the maximum number. Maximum number should be n minus 1. So what we come to know? There is, if n is the natural number which has a factor other than 2 or 5, then 1 by n will have a non-terminating recurring decimal expansion. Since it is recurring, therefore some blocks, some digits will be repeated, and the digits which are repeated, they are called the repeating block. In that case, the maximum number of digits in the repeating block will be n minus 1. Now suppose 1 by 7. Now 7, it has factor other than 2 or 5, because the factor is 7. The maximum number of digits in the repeating block can be 7 minus 1, that is 6. Actually 1 by 7 is equal to, if you divide, you will get 0.142857 and so on. I mean, you see that these numbers 0.142857, these are repeating. So they are called repeating block, and the repeating block consists of 6 digits, 1, 2, 3, 4, 5, 6. So numbers in the repeating block are 6. Numbers in the, therefore, numbers in the repeating block are 6. Now next, our discussion topic. Next, our discussion topic is, that is, representing real numbers on number line. Number 2, representing real numbers on number line. on number line. Now I am discussing this one. Actually, this is to visualize a real number on the number line. Example, I am taking one example to explain this one. Visualize 3.65 on a number line. So this is the question. To visualize 3.65 on the number line. Now step 1. Step 1. 3.65, or say it is 3.765. If we are doing a difficult one, other sums I think you can do. Number 1 step, 3.765 lies between 3 and 4. Okay. So what happens if this is the number line and on the number line this is 3 and this is 4, then the number 3.765 lies somewhere between 3 and 4. But where is the number? Now what we have to do? We have to enlarge this division. There is the space between 3 and 4. Say this is 3. We are magnifying this one. This is 3. 3 means 3.0. Then this is 3.1. This is 3.2. This is 3.3. 3.4. 3.5. 3.6. 3.7. 3.8, 3.9, then 4.0. Now step 2. Step 2. 3.765 lies between where 3.7 and 3.8. Clear? So what we have to do? Again we are drawing the number line. That is, now we come to know that the number lies between 3.7 and 3.8. Now we need to magnify this one. First, we magnified the space between 3 and 4. Now we will magnify the space between 3.7 and 3.8. Say this is 3.7. I mean this is 3.70. So obviously this is 3.71. This is 3.72. This is 3.73. 3.74, 3.75, 3.76, 3.77. So this is 3.76, this is 3.77, 3.78, 3.79, 3.80. So what we get, the number lies between 3.76 and 3.77. That is, the number lies here. Now we need to visualize this part. 3.76 and 3.77. So the number lies between, next we'll say the number lies between 3.764 and 3.766. Okay. Now for step 3 we will write, for step 2 what we have written, the number lies between 3.7 and 3.8. Next the number lies between 3.76 and 3.77. Okay, the number lies between step 3, the number lies between 3.76 and 3.77. Next, now you see what is the number 3.765. So 76, clear? 3.76 and 3.77 we have said. Next, step 4. In step 4, the number we will show, the number lies between what? 3.764 and 3.766. Now let us see. It is the number line. So say this is 3.760. I mean 3.76. So this is 3.76. As this was 3.7 and this is 3.8. Clear? So similarly we are going to represent that one, the number in between 3.76 and 3.766. Now this is 3.760. So this is what? 3.761. This is what? 3.762. This is what? 3.763. This is what? 3.764. This is what? 3.765. So this is 3.761. 3.762, 3.763, 3.764, 3.765, 3.766, 3.767, and so on. So what we get, ultimately we get, this is the position of 3.765. So if we assume that 3.765, which lies between 3 and 4, it is suppose the position is here. If we are supposing this one 3.765, so this is ultimately where, this is ultimately, we are able to show that this is ultimately here. Now this is to be noted that 3.765, how many decimal? 3 places of decimal. Clear? 3 places of decimal. And how many digits? 1, 2, 3, 4. 4 digits. 1, 2, 3, 4. 4 lines. 1, 2, 3, 4. 4 lines will be there. Clear? So this is how to visualize a real number on the number line. Next, we are going to show you, I am going to show you how to represent a square root number of decimal number on the number line. Clear? Decimal number on the number line. It is actually how to find the square root of a decimal number through construction. So let us see, through one example I will do that. Represent under root of 6.5 on number line, or calculate under root of 6.5. Okay, how to find the square root of 3.5? So let us see. First, under root of 6.5, we need to write this one as the product of two numbers. Okay, as the product of two numbers. As the product of two numbers means, suppose we have written this as 1 into 6.5, we can write. Okay, so first let us draw a line. Use geometry box to do that, though I am doing this in free hands. So this is the line L. Clear? Now what we will do, there are two factors, 1 and 6.5. Any two factors you can take, but exactly two factors you should take. Okay. That is, you can also take that, this is, you can take 1.3 into 5, you can take, not a matter. So we will take, I am taking this one, we will take one line of length 1 and another line of length 6.5. So 1 plus 6.5, that is equal to 7.5. So a line of length 7.5, that is equal to, say, this is AB. So suppose this is A and this is B, which is 7.5. centimeter. Now 7.5, this comes in what way? 6.5 plus 1. Suppose AO, this is 6.5 and OB is 1, so total is 7.5. Now let us bisect the line segment AB. Say this is the midpoint. You know how to find out the midpoint geometrically. You all have learnt in your previous classes. Say this is the midpoint, which is M. Taking M as center and MA or MB as radius, let us draw one semicircle. Okay, let us draw one semicircle. So say this is the semicircle. So this is the semicircle that I have drawn. Now this is one. So through these, let us draw a perpendicular. You all know how to draw perpendicular. Clear? I think you all know. Let us draw the perpendicular through O. So this is the perpendicular. This is the perpendicular which intersect the semicircle at the point D. Clear? At the point D. Take the measure of D. Take the measure of D, taking O as center and OD as radius. Let us draw the arc. So this is E. Now this is 1, this is 2, this is 3. So we can say that under root of 6.5, it lies between 2 and 3. And this is the position of that number. Clear? You measure this length OD. So OD will give you under root of 6.5, which will come approximately 2.5. Almost 2.5, not accurately, almost 2.5 centimeter. That is 2.5 you will get. So this is 2.5. In this way, you need to represent square root of any decimal number on the number line or to calculate the root of the number. Now to rationalize denominator. Rationalize the denominator of irrational numbers. Okay. Now how to rationalize the irrational number? If the irrational number is of the form 1 by root x, we will write this as, this is number 1 procedure, 1 by root x into root x by root x. Since we know that root x by x, root x into root x is equal to x, so this is called the rationalization of the denominator. So that is removed. Number 2, if we see that the number is in the form 1 by root x plus minus root y, we will rationalize this one as root x plus minus root y into root x minus plus. If plus, then use minus. If minus, then use plus. Root y by root x minus plus root y. Then a plus b, a minus b. a minus b, a plus b, a square minus b square, and the root from the denominator will be removed. That is, this will be under root of x minus plus under root y by x minus y. Clear? So generally these are the form how to rationalize this one. Sometimes you will be asked to find the values of a and b whenever a rational number is compared, that is whenever an expression is compared to the irrational expression. Like I am showing you, if you were asked 2 plus root 3 by 2 minus root 3 is equal to a plus b root 3, then find a and b. How to do that? 2 plus root 3 by 2 minus root 3. First let us rationalize this one. 2 plus root 3. This is 2 minus root 3. Let us multiply both the numerator and denominator by the opposite side of this one, that is 2 plus root 3 by 2 plus root 3. So this will be 2 plus root 3 whole square by a minus b, a plus b, a square minus b square. That is equal to 2 plus root 3 whole square. That is equal to a plus b whole square, a square plus b square plus 2ab. That is equal to 437 plus 4 root 3. Now we are given that 7 plus 4 root 3 is equal to a plus b root 3. Comparing we will get a is equal to 7 and b is equal to 4. So these are the values of a and b. That is, now exponent. If it is in the exponent form, so you should know the laws of exponent for real numbers. What are the laws of exponent for real numbers? Number 1, x greater than 0, y greater than 0. Then x to the power p into x to the power q is equal to, x to the power p plus q. Then x to the power p divided by x to the power q is equal to x to the power p by q. X to the power p whole to the power q is equal to x to the power pq. X to the power 0 is equal to 1. X to the power minus p is equal to 1 by x to the power p. Xy to the power p means x to the power p into y to the power p. X by y to the power p means x to the power p by y to the power p. X by y to the power minus 1 is equal to y by x, and so on. Similarly, x to the power root n is equal to x to the power 1 by n. Clear? X to the power 1 by n. Cube root of x is equal to x to the power 1 by 3 and so on. Okay, so up to this for today. Our total discussion on the number system of real numbers, it is completed today. Now we are in a position to solve the exercise from NCERT book. I will also give you some questions related to this as your worksheet. Okay.